Okay, welcome to this lesson on quadratic functions. If you watched the previous video on the quadratic formula, we kind of finished off with a bit of excitement about the fact that a quadratic equation had no solutions. Because this value under the square root sign was negative. And I painted a picture of what that meant in terms of the graph. So I'm just going to start by going back over that for a function, for a graph here on the left hand side that just touches the x-axis at just one point, x-axis, then what we can say is that it's got one point of contact, therefore the equation equals 0 will only have one solution. Because there's only one point of contact, that's one solution. Because remember, the solution is always when the y coordinate equals 0. The second one, the red function, we know it's a negative x squared term because it's a frown as a maximum turning point. And the x-axis here there's 2 points where the curve cuts the x-axis. There's two coordinates where the y coordinate is 0. Okay, and therefore there's going to be two solutions to the equation equals 0. Okay, whatever the original function was, there are going to be 2 points of contact, meaning two solutions. And when we were doing the quadratic formula and we found there was no solutions to the equation, that just meant there's no points where the y coordinate is 0, no point where it cuts the x-axis. So that's the connection between the solutions to an equation and what the curve looks like, as in its position relative to the x-axis. So today's question, or this lesson's question is there a way to predict the number of solutions without drawing a graph? See these ones that I had here, 1, 2, or no points of contact. Just by looking at an equation without having a picture, could we predict that? And the answer, of course, is yes. So hopefully you've been introduced to the quadratic formula. If you haven't, I would watch the video first because it's based on this. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, remember that? We'll get rid of there. So what we found in our example where there was no solutions was this was negative 31, remember? So in other words, the crucial point of the quadratic formula is this part here. Now if I remove that and leave that as a space, I just want to consider some numbers here. It doesn't matter what the value of b or a is, okay? They'll always be integer values, okay? So let's just think for a moment. Say for instance, b squared minus 4ac was, pick a positive number, say 5. Okay? Say that value was 5. Well, the square root of 5 is going to be somewhere just between 2 and 3. Okay? But it is a positive number. In other words, we'll be able to subtract 2 and a bit from negative b, and we'll be able to add 2 and a bit to negative b, and we'll have two solutions. So if the number under the square root is 5, or even 10, or 2, or 1, then we'll get two solutions because we'll be able to split up the quadratic formula into x equals negative b minus the square root of 5 over 2a, and we'll also have x equals negative b plus the square root of 5. Okay, we definitely get two solutions. Okay, what would happen if, so basically as long as this number under here is positive, we're likely to get two solutions. What would happen if b squared minus 4ac was 0? What would happen if that was 0? Well, obviously square root of 0 is 0, so we'd have nothing there, and all we would have would be x equals negative b plus nothing all over 2a, and because we don't have the opportunity to put plus and minus, we're actually only going to get one solution. So whatever negative b over 2a is, that's our one solution, and that's why sometimes we only get one. And we found out in our quadratic formula example that if b squared minus 4ac, if that number is a negative number, say for instance, negative 4, well, then the wheels come crashing to a halt because we can't actually find the square root of negative 4. And so there are no solutions. Now, we can generalise that by saying not just b squared minus 4ac equals 5, we can actually say as long as it's bigger than 0, then we'll actually get 2 solutions. Because as long as it's positive in some sort, we can always find a square root to add or subtract, okay? And we can also go as far as to say any negative number is going to give us 0 solutions. So what we've got here is a little bit of a test, a little bit of a check. If we just calculate b squared minus 4ac on its own, depending on the value of it, we don't have to go through the whole formula if we just want to know how many solutions there are. And because that's a wee check, because it classifies, it groups them into 3 different categories, we call it the discriminant. To discriminate means to separate or to categorise. So therefore, we can categorise into 3 different groups, 2 solutions, 1 or 0. Okay, so this to summarise, okay, I should have really checked to see if I could fit all this into the screen. We can just about, now this is really important. So if you can take a screenshot or pause this, in fact, pause it and copy down this information or take a screenshot, super important, right? This is it's all summed up. So what we're talking about here is the nature of the roots. That's today's word. The nature of the roots is found by the discriminant, okay? So let's think if b squared minus 4c is greater than 0, as we found, the number under the square root sign is positive, we can find one, okay? Then, do you know what? I deliberately mixed these up. See if you can notice. Yep. There will be 2 solutions. Okay, I originally had it all mixed up for my students to do. There'll be 2 roots. So there's a picture of what that would look like on a graph. 2 points, it cuts the x-axis. What we say about the roots is they are real and unequal. The roots are real numbers, and they're unequal because they're 2 different values. So if you discover that the discriminant is greater than 0, you can say the roots are real and unequal. If you discover that the discriminant is 0, then you can say that the roots are real. And although technically there's 2 roots, we imagine them as overlapping, sitting on top of each other, so it's actually only 1 unique value. So we say the roots are real and equal. There's 2 of them, but they're the same. And if we say the discriminant is less than 0, then here's an interesting one. There's no solutions to the quadratic equation, but we say that the roots are not real, okay? It suggests that there are roots, but they're not real. What does it mean, not real? Well, that's a topic of discussion if you were to go and to do more advanced mathematics. There's something called imaginary numbers. I'm not joking, okay? Imaginary numbers. They're not real, they're imaginary, and we find that we can work with the square roots of negative numbers. But as far as we're concerned, it's not that it's impossible. We just say the roots are not real, there are no solutions. Okay, so these green quotes are part of your answer, so make sure that you've got them written down. Okay, so let's try and do a couple of these examples. By calculating the discriminant, state the nature of the roots of these equations. Okay, so just the nature. We're not asked to solve the equations, but we're asked to state the nature of the roots. So what we want to do is simply to write down, as though we're using the formula, a equals positive 1, b equals negative 4, and c equals positive 4. And all we want to do is to work out the b squared minus 4ac bit. So what is that? B squared is negative 4 squared minus 4 times 1, which you could put it in brackets, 4 times 1 multiplied by 4. So negative 4 squared is 16. Subtract, or negative 4 times 1 times 4 is negative 16. And that gives us the answer 0. B squared minus 4c equals 0. You go back to your table. Hopefully you've got it written down. You consult the grid. If b squared minus 4ac equals 0, there will be one root. And we can see the roots are real and equal. So we write down as b squared minus 4ac equals 0. The roots are real and equal. Okay, in other words, there's one solution. Let's have a look at the second one. 2x squared minus x plus 7 equals 0. In this case, a is 2. B, be careful, is negative 1. And c is positive 7. So we can say of this one, b squared minus 4ac is equal to negative 1 squared minus 4 times 2 times 7. Negative 1 squared is positive 1. Negative 4 times 2 is negative 8. Times 7 is negative 56. And we get the answer negative 55. In other words, picture that number under the square root sign in the quadratic formula. That's a big no-no. We would get no solutions. So therefore, as b squared minus 4ac is less than 0, you're always going to put a 0 on the right hand side. So either greater than, equal to, or less than is less than 0. What are the nature of the roots? The roots are, well, in this case, not real, isn't it? Let's go back. The roots are not real. There are no solutions, but the correct mathematical term to write down is the roots are not real. Okay? Now, that is, we're nearly there, but what I want to do is to change the question, the wording of the question, okay? Look at this, determine the nature of the roots of the function. Remember, we're talking about roots being the x-intercept points, roots. Do you notice that's different by state the nature of roots of the equations or the solutions of the equation? So we're talking about nature, but it's a root of the function and not a root of the equation. But it all means the same thing. And again, we've got function notation here. It doesn't matter if it's y equals or f of x equals. In this one here, a is positive 4, b is negative 7, and c is positive 8. So we can say that b squared minus 4ac is equal to negative 7 squared minus 4 times 8, which is 49, and then 4 times 4 is 16, 16 times 8, 16 times 8 is 80 and 48, which is 128. What's that? 78, 17, negative 70, 49, take away 128, I'm getting 79. Okay, and what we've got there is a negative b squared minus 4ac as b squared minus 4ac is less than 0. The roots are, what are they? Shout it out. Not real. Good. And the last one here, if you want to pause the video, you could try it yourself because I'm about to go over the solution. A is negative 3, b is 5, c is 12, so b squared minus 4ac is equal to 5 squared, I'm just going to write down 25, minus 4 times negative 3 times 12. Watch that negative. As soon as you put a negative in one of these brackets, it means that we're going to have a clash of signs here. So we've got 25, you've got negative 4 times negative 3 is positive 12, and 12 12s are positive 144, which is 169. It's positive. What does that mean? It means we could find the square root of 169. It means that there's going to be two solutions. As b squared minus 4ac is greater than 0, then the roots are, there's going to be two solutions. Roots are real and unequal. So roots are either real and unequal, in which case there's two different roots, or they're real and equal, which means there's just the one root. Okay, so I'm going to stop there because there's another little bit where we play around and introduce unknowns, variables in this, but I'll make that the next lesson so that you can go and practice just finding the nature of the roots of the function. It's called the discriminant, and it's a really useful tool. Hope that's been helpful.